Hi, everyone. I'm really glad to see all of you today on our first day of the pairs trading workshop. Let us start. So first, I think many of you know about Hudson and Thames and what we do, but just as a quick intro for those of you who maybe don't. So we are an engineering company and we build implementations of algorithms that are described out there in the quantitative finance literature. And here you can see three our main packages that we present, and they deliver specific use cases for users. Those would be ArbitrageLab, MLFinLab, and PortfolioLab. Just a brief description here. So ArbitrageLab is dedicated to statistical arbitrage and pairs trading algorithms. And many of the things that we are going to be talking about during these 2 days of the workshop are related specifically to that topic of quantitative finance. Then we have the MLFinLab, which is centered around machine learning techniques. And it was mainly works of Professor Lopez de Prado, so 2 of his widely known books, plus some of the implementations from his papers that weren't included in those books, as well as we added some extra modules, be those data generation, backtest overfitting, as well as networks, and maybe some extra ones for you to use and check out. Plus, there is the PortfolioLab package, and the sole goal of this package is to implement a lot of algorithms dedicated to portfolio optimization, and we have algorithms ranging from standard Markowitz optimization and all the way to some complex clustering algorithms, be those HRP from the Prado, HRC from Dr. Raffinot, or NCO, whatever. If you are interested in portfolio optimization, I encourage you to look at that. For MLFinLab and PortfolioLab, they are available on PyP, Python package index, so you can just quickly pip install them, plus a part of the documentation is open to start using them. For the ArbitrageLab, it's a paid-for package, and details on that you can find on Hudson and Thames webpage. Now to the series of these 2 days of presentations. Today it's going to be rather a short one, maybe closer to 40 to 45 minutes, my presentation regarding an overview of pairs trading strategies. The main idea behind this was to introduce you to pairs trading strategies, how are they classified, what are the differences between them, and so that you would know more about the field that we're going to be discussing on tomorrow. Today, there are not going to be any specific formulas, algorithms, it's just an overview, so to say. But I'll also point you to places where you can find the algorithms themselves, as well as the descriptions of them if you would wish. Tomorrow is the main event, and it's going to be 3, maybe even 3.5 hours long. So it starts at 6 p.m. London time and ends, I think, a bit later than 9 p.m. London time. And we're going to cover 7 distinct presentations from 3 of our apprentices. So the first 3 presentations are going to be presented by Joanne, who was working on developing the distance approach. And don't worry right now about the different approaches that I'm mentioning. In a few slides, you'll understand completely how the pairs trading field works in our understanding. So the first 2 presentations entirely dedicated to distance approach strategies. The third presentation is dedicated to hedge ratios estimation models. Then the next 3 presentations would be covered by Vijay, and those would be mainly on the stochastic control field, so part 1 and part 2, but also we're mentioning their partner selection using copulas, which are from the Copula approach. And the 7th presentation will be by Franz, who I believe is right now in this webinar, and he'll introduce us to canal filters in time series analysis, which is essentially a problem of time series approach. It will be more of a theoretical overview, but still very, very interesting. The plan for tomorrow's presentation is about 20 to 25 minutes per presentations, plus a 5-minute Q&A after each presentation. Today, my presentation will take maybe 40 minutes, maybe a bit less, and then we can have an extended 10 to 15-minute Q&A, not only related to pairs trading, or maybe you have some questions about ArbitrageLab or other packages, but we can in general discuss various topics. It would be, I think, of a great interest. Let's go on. Quick note about me. My name is Illya Barziy, and I'm a quantitative research team lead at Hudson and Thames. I have master in computer science in and econometrics in the University of Warsaw. Here are some links to my GitHub, Twitter, or LinkedIn. And if you either want to follow us to check some of the futures events, please do that. As well as we can carry out some of the conversation outside of this event today to discuss maybe in some more detail some aspects. Please feel free to. Finally, the main part of the presentation, an overview of pairs trading strategies. And here I should probably mention that not all the papers that are in the field are obviously highlighted. There is a really broad range of literature. And what I'm covering here are only the core papers, and even the core papers that we decide to implement and showcase and to discuss upon. So if you would like to really dig deep into, you'll have to use some tool, for example, as connected papers, and just scroll through various papers to find the exact thing that you're looking for. It's a rather long trip, but I hope that after this presentation, you'll have a much deeper and broader understanding of what's going on out there. So this is the general structure of today's presentation. And as you can see, it's divided basically by approach. I'll go piece by piece and highlight the core idea of the approach, as well as main papers or textbooks contributing to this particular topic. In the end, you can also find a list of full references for those of you who would like to check the original sources or just get a more understanding of the specific algorithm that I was describing. Introduction. This presentation is based on the paper by Christopher Krauss, and this is a great paper for you to get introduced into the topic, and the name is Statistical Arbitrage Pairs Trading Strategies. The main idea is that it rose a problem that over the past 2 decades or so, there were many pairs trading strategies, and different authors call them in a different ways. They can call them statistical arbitrage or pairs trading, but essentially we call it pairs trading in this particular presentation. There are too many of them, and they should be in one way or the other categorized based on their nature, based on the behavior, and based on the logic inside. And Krauss proposed 5 distinct approaches to pairs trading that are divided by their logic. And he also provided some core papers and descriptions in a broad form for you to get to know these approaches better. What is a pairs trading strategy? So as we start, this is a general description from a paper, Gative and others from 2006, which is the most widely cited paper in the domain of pairs trading in general. And they define a logic behind a pairs trading strategies as: first, we would pick two assets whose prices move together historically. Worth noting that assets cannot be individual elements, but also a portfolio of elements. Then we would monitor the spread between them during some periods. And in general, if the prices would diverge, we would short the winner and buy the loser. Rather simple approach, but based on how vague it is, you can kind of think of, hey, there are a lot of things that can be done in one or the other way. And that is essentially why there are so many papers on this topic. They can also be classified by the nature of spread construction. So to say, if you would be trading one asset versus the other, it would be a univariate strategy. If you would trade one asset versus a bundle of assets, or a portfolio, that would be a quasi-multivariate setting. And finally, if you would be trading portfolios against each other, that would be a truly multivariate setting. Now, how can pairs trading strategies be classified in with respect to their nature of the strategy itself? First, there would be a distance approach. The main idea is that we're using simple non-parametric distance metrics, and then some simple set of rules to generate trading signals. An example of this would be taking squared distances of normalized prices, as in the paper by Gative, and then applying some simple thresholds of divergence of these normalized prices to generate the trading signals. Rather simple. Then we have the Cointegration approach, and this usually requires stricter co-movement of the assets or portfolios that we're treating. Those would require basically cointegration testing in this or the other form. It may be more strict, less strict, but it just requires those. And those would be the cointegration, the strategies from the cointegration approach. Then there is the time series approach, and authors in this domain in general omit the question of picking pairs whatsoever and expect that the user already knows which two assets or portfolios he or she would like to trade. And it solely bases on trying to somewhat forecast or model the price. And based on the difference between modeled price and the actual price, we would generate a trading signal. Then there is a stochastic control approach. And the core idea here is that you would identify some optimal trading rules or optimal weights for elements in a pair related to the statistical properties of the process of prices or the process of spread itself. Finally, what Krauss defines as other approaches is a series of relevant papers in the field, however, not enough papers or materials to gather them in a distinct way. But we extend this a bit and decide, for the sake of this presentation, to call them specific separate approaches. Those would be a machine learning approach. Based on the name, you would assume that, yes, right, it bases a trading signal generation on some machine learning technique, be that neural networks, support vectors, whatever. Then we have the Copula approach, and here the main idea is just to use a mathematical concept of Copula that I'll not deeply explain, but I'll link you to the sources that can easily explain that to you, so you would be more familiar with this tool, as this is great and pretty novel, and not that much research was done actually in the topic of Copula pairs trading. And finally, we have the PCA and other approaches. And here we mainly have the PCA approach and also some other minor papers here and there. So I hope after this quick, rather introduction, you have a general understanding of what's going on right there in the pairs trading field of paper and methods. First, the distance approach. Tomorrow's presentation, as I already mentioned, two of them will be dedicated to distance approach, and essentially what I'm outlining here will be described in much more detail, and Joanne will do a great job in this. So I really encourage you to come here tomorrow and check those presentations out. But what is worth mentioning here? So the first would be distance, basic distance strategies and adjustments to them. As I mentioned, the paper by Gatif and others is the most cited paper in the domain of pairs trading in general. And it proposes a really simple algorithm that was, in addition, robust to data snooping bias. It was backtested on, I believe, data set of US stocks from 60s to 2002, and it showed abnormally high returns. And since a whole basket of stocks were picked for the original strategy, as I said, it was robust to data snooping, and it produced a great discussion in the field, and a lot of subsequent papers went out to either empirically test the result or determine what is the nature of those returns. Unfortunately, after about 2005 or so, based on works of other researchers, the profitability of such an approach degraded. And also, if transaction costs would be taken into account, this would be even worse. What's the upside, though, is that a paper by Du and Pfaff, released in 2010, both does a great overview of the original strategy, proposes various adjustments to it, and those adjustments actually show improved returns and profitability. But yeah, in general, it gave a new breathe to the standard method. More on that topic you can check out tomorrow on Joanne's presentation. Then there is a quasi-multivariate extension. So the previous one was the univariate one, and right here, authors propose a set of strategies that would extend this to a quasi-multivariate setting. Essentially, they're using alternative metrics to identify pairs there, such as Pearson's correlation and others. You'll essentially check this out tomorrow in more detail. But the upside here is that it showed more robust results, and plus, since the papers were released a bit later, they had a broader backtesting timeframe, which showed improved performance in comparison to the standard gated and all approach. It's worth also noting that there are a lot of strategies in this domain, but it's also worth noting that they're usually either an empirical testing of such or such variation of the basic strategy, or an adjustment of distance strategy to some particular market. There are papers just dedicated to setting this strategy to be optimal in a commodities market, for example, or adjusting it to a high frequency trading setting, and we're not adding them to this presentation. But they're described in the original Krauss paper, so if you'd like to check them out, there's the source for you. Now, the second approach that we will describe is the Cointegration approach. And to get a deeper information about this, I encourage you to check our YouTube recordings from Yifeng, who did a great video on minimum profit optimization, plus also a sparse mean reverting portfolio. You would basically understand the concept itself as we're doing right now in this webinar. The core strategy in the Cointegration approach is described in the book Pairs Trading by Illya Barziy, and it is proposing a three-step framework of pre-selection of potentially configurated pairs, then testing them for tradability, and essentially optimizing the target levels to get the optimal expected return from the strategy. It's also interesting to note here that even though it's under the Cointegration approach per se, the original approach didn't, the original strategy didn't in particular require for the Cointegration testing, and instead opted for a strong mean reverting property, which is rather interesting. The second element of the Cointegration approach is the minimum profit optimization. And these are a set of strategies that would optimize the minimum profit, even though it doesn't sound really exciting like minimum profit. But essentially, what we are trying to do here is maximize the worst case scenario in the trading setting. So the first paper, I believe, is one of the first in this domain, and the second one is an adjustment to the original one. To briefly describe how it works is we have a testing period or training period, however you would call this, and we observe a process of spread, and then based on how it behaves, we can set optimal levels to enter or exit the strategy, and we would try to get the maximum expected minimum value that we can get out of the trade. There was a critique to the original paper that, hey, and it was described in the previous work by Illya Barziy, that expected general return from a pairs trading strategy and from a strategy is a function of number of trades and the, so to say, performance or the profit per trade. And the original paper was focusing mainly on the profit per trade and not taking into account the general number of trades. So the second paper fixes that issue and proposes a more adjusted framework. There are a few downsides, however, to this, one of the biggest being that there is a specific requirement for the Cointegration error to be a symmetric process plus an AR1 process. But if your specific problem fulfills that, then it's a really good element to use. The other downside is a quite complex, so O big of n cube time complexity of the algorithm. However, I believe that there is slightly optimized, I may be wrong here, slightly optimized algorithm, which is O big n square log n that we're using in our implementation. And then the last element in the Cointegration approach is the sparse mean reverting portfolios. It's not widely described in the original Krauss paper, but we found it of a great interest, and also some practitioners were mentioning it as a core element of the pairs trading strategies. What's interesting about this? Well, probably the most interesting thing that it actually opts against the standard Cointegration testing as a way to determine weights for trading assets. Because when we would, for example, use either standard angle Granger or Johansen tests to determine weights to trade a pair of elements, we would get that these are dense portfolios, which means that we have coefficients for every element in a portfolio. And if we are rebalancing frequently, these are high transaction costs. Plus, if we have coefficients for each of them, it's lower interpretability, not that good. You can obviously cut out some of the lower coefficients, but you're not specifically sure how to do this. So Daspermont proposes a great approach to this, which is essentially taking into account the correlation matrix of the assets, then generate a sparse mean reverting portfolio. So a great portfolio that would at the same time be mean reverting, but it would require as less elements being added to it as possible. And as I said, there is a great video from Yifeng on this topic. This method, so this problem can be solved as described in the original paper by two methods, either greedy search or a convex relaxation. The first is a bit quicker, but gives worse results. The second gives better results, but requires a bit more time to run. And as I said, the upsides for this are improved interpretability and lower transaction costs in general. To the time series approach. It's worth noting at this point that the time series approach is still being kind of under development in our packages. And another thing worth noting is that the Kalman filter time series approach strategy will be described tomorrow by Franz, even though in the more theoretical setting, it's still worth understanding it in more detail. And even if you would like to use, for example, Kalman filters in some of your strategies as a separate element, not as a part of this trading strategy, it's a really good presentation for you to visit. Next, essentially, yes, pairs trading with the Kalman filter. And the main paper in the domain of pairs trading with time series is this pairs trading by Elliott and others. It's the most cited in the domain, and the main idea behind this is we assume that we can describe the spread as a specific state space model, and its parameters we can estimate using the Kalman filter. We essentially, as I said previously, in the time series approaches, we would forecast the value of the spread process, or in some elements would be forecasting probably also maybe prices or returns as processes. And based on this forecast, we can later apply filters, and these filters would allow us to generate trading signals. Those filters can be similar as threshold filters. They can be something more complex as adding an Ornstein-Uhlenbeck on top of the model. So there's like quite a lot of things to check out. And I believe if you'll be here till I will be presenting for the machine learning approach, there is a much larger basket of tools for you to use if you're interested in this specific approach. So forecasting a process and then applying a filter to the forecast and real price to generate a trading signal. And here is also a paper, it's rather a textbook by Sarmento and Horta. It's not that widely mentioned in the literature, but we decided to add it here as well. It's rather versatile, and based on the original descriptions of the author, it showed good success in the empirical setting. And the idea here is that it consists of two elements. So first, you would need any forecasting algorithm. You can use Kalman filter, you can use ARIMA, and anything up till neural networks or maybe some more advanced stuff. And then you would check what is the difference between the actual forecasted value and the real value, and based on to which quantile does this value falls, you would generate a trading signal. Changing the sensitivity in this method is available by changing essentially the quantile at which you would be deciding to generate a trading signal. Now we can move to the stochastic control approach. Tomorrow's two of the presentation will be dedicated specifically to this approach. VJ will do them, and you'll be able to get a deeper understanding, as I said, to the stochastic control field. First element in this approach is the Ornstein-Uhlenbeck based models. And a general assumption here is that our spread follows NU process, and we have some extra elements added to it. Those could be expectations of the trader, maybe volatility of the market, and some extra inputs here and there, which allow us to essentially construct a model with specific use case that would give us, in some cases, that could be optimal weights for the legs of the spread, the legs of the spread, yes, so the first asset and the second asset, as well as maybe entry and exit levels. These two elements support different utility functions, so based on the interest of the agent who is doing the trade, they can be adjusted. It's also interesting that these models actually show that it's not optimal always to enter a trade, and there might be sections where you would be better off taking out of the trade. And essentially, Vijay will cover this in his tomorrow presentation. Now, the next element here would be the optimal convergence, and the main paper in this domain is by Liu and Timmerman. You can think of this as an extension to some of the previous models, however, much more advanced, because it not only looks at the spread, but it assumes that both prices move with a specific model in mind that takes many elements into account. And however hard may be inside the derivation of these models, they actually show good results. It's also worth noting that in these models, two opportunities types take into account the recurring and non-recurring, which means that theoretically you can have a setting where you can trade only once and get the most out of the trade, or you can trade multiple times and accumulative gets a lot from those trades. So there are solutions for both of them. Also, here are some extra insights from those models. These models show that actually sometimes it may be profitable to hold both assets in a pair, either long or short, or maybe it's worth holding only one of the assets, whereas not holding the other, which is kind of contradictory to the standard pairs trading strategy logic that I described in the initial slides. Now, the optimal mean reversion trading, which is a, you can say, standalone element because it's also not included in the Krauss overview, but we believe that's because the elements presented here are essentially posted outside, so after the original overview paper was released. And here we're adding two works. So first would be a textbook from Professor Liu and Lee, and the other would be a paper from Professor Lipton and De Prado. In the first textbook, the idea essentially that, hey, let's assume that our spread process, you can say, follows a particular distribution and process. Those three processes are covered in the original work. Would be Ornstein-Uhlenbeck model, which is also widely used in different other pairs trading approaches, exponential Ornstein-Uhlenbeck model plus a Cox-Ingersoll-Ross model. Even though the first one is the most widely used, it proposes optimal levels for this strategy, meaning that you provide it with some training period of the spread, and you can also add there, for example, stop loss ratios that you prefer, or maybe trading constraints or transaction costs that you're incurring during the trades. And you would essentially get as simple as just the output of, hey, here is the level for you to enter, and here is the level for you to exit, taking into account your inputs, which would give you the optimal output and the optimal profitability per that trade. And it's worth also noting that this can be adjusted to both only single opportunity and multiple opportunity, as was in the previous slide. So you can either decide that, hey, I want to get the maximum out of one trade, or I would preferably trade multiple times and get the cumulative maximum from that. The second paper by Professor Lipton and De Prado takes a bit different approach, but still takes into account that our spread may be distributed and may be an Ornstein-Uhlenbeck process. And by solving it from a bit different perspective, also gives you the optimal levels for you to use in the trading strategy. And that's when we're finished with the stochastic control approach and moving on to machine learning approach. Maybe a lot of information at the same time. Be sure I'll answer any of your questions afterwards. This is just for you to be informed in general in the field of pairs trading, as I said in the beginning. So the machine learning approach. Here, as I said, essentially any method using machine learning would apply, but in core, it's really similar to the time series approach as well. You can see this from the second slide that I'll be presenting in this topic. If you would like to check out more detailed description of these methods, there is a video recording from Aaron, who is right now on this webinar, that you can check out. It's on our YouTube channel to get a deeper understanding into machine learning and pair selection methods. So first would be here machine learning and pair selection. And we decided to showcase this as a separate method, even though not also covered in the original Krauss paper, because it provides a really great framework for people who are searching for pairs to trade in their strategies. Because essentially, if you approach this problem, you can either go with a distance approach, so some simple non-parametric tools, or you can use Cointegration, strict, or like strict in the sense of angle grandeur or Johansen test, plus maybe less strict as proposed by Vidya Murthy in his work. You can maybe for the Copula approach that we'll cover, use some statistics as Spearman's Rho or Kendall's Tau to determine pairs to trade. There are multiple ways, but here is a general, really good algorithm and a framework for you to use, which addresses essentially the problem of, hey, how would you find good pairs to trade? And it consists of 3 steps. So first would be a dimensionality reduction that would allow us to get a compact representation of the assets. Then there would be an unsupervised learning clustering, where we would cluster our elements in the space. And in the very end, we would get some pairs using our pair selection criteria, which are multiple out there, starting from strict Cointegration testing, checking the Hurst exponent, checking how often the spread actually deviates to 0, so how often will possibly a trade be performed. Really encourage you to check our implementation of this paper and to check the original work in general. The second, and here are rather a lot of papers, but I assure you there are much more papers on this domain. They are written by Dunis and also other researchers. I highlighted here 3 that are probably the most important and the most cited. In reality, I think there are more than 6 of them, being of a maybe similar nature, but of a really similar concept. So to trade some specific spreads, those could be gasoline, as you can see, soybean, corn, ethanol, etc. There is a general, so to say, framework to use that would consist of either so modeling this spread using some machine learning elements. In this case, these are multiple neural networks, and they are like a lot of them that can be used in this approach. And second element here would be applying a filter, which can be a symmetrical, asymmetrical filter with different variations that would take the expected, so the forecasted value plus the actual value, and based on this would generate a trading signal for you. Again, encourage you to check Aaron's presentation on YouTube on this regard. Plus, this particular element takes into account the threshold autoregression model that adjusts the trading process. Then we have a Copula approach. I remember that I said that I'll explain this, but there is generally no, in my understanding, better way to get and understand Copula than to read one of our blog posts, the introduction to basic Copulas for pairs trading and introduction to advanced Copulas for pairs trading. You can find them on our Hudson and Thames webpage, as well as on YouTube. There are great materials by Hansen who recorded them. And even though they might feel complex, it's a great topic to discover, because based on some of the latest papers, this is a great tool to use in pairs trading scenarios, because it shows more robust results with excess returns abnormally in some trading settings. I'll elaborate on this and give you a reference paper in a bit. So right here we have what you can call maybe basic Copula strategies. Those would be papers by Liu and Wu, Stander and others, and also an adjustment using the mispricing index by Xie and others. What is interesting here is that, okay, so essentially, a copula is a form of representing the relation between two assets, and they can follow some mathematical statistic relations. We have two elements here. One would be a training period, where we would get the observations and then see which copula fits our observations the most, so that we can kind of see the relationship between the elements in a more strict format and not just the empirical observation. And then during the trading period itself, based on where we see the prices in this probabilistic space, we would generate a trading signal. For example, this may show us that, hey, if this particular situation of different returns or different prices occurred, there is a high chance that one asset is underpriced and the other is overpriced. And this is extended using the mispricing index in the last paper here by Xie, which adds a general higher level layer on top of the basic copula strategy here. We can also have a look at fine copulas, pair selection, and trading strategies. And fine copula is an extension to the original idea of copulas. Both of this, so the pair selection and the trading strategies, are mentioned in this, and not mentioned, but basically in detail described in this paper by Stübinger and others. And you can actually see that one of the authors of this paper is Krauss, who is the author of the original overview. That's why it's not included in the original overview, because it was released, I believe, 2 years later. So first, to the pair selection element. This is a great tool, again, for pair selecting, to select pairs for your trading strategies. The interesting element here is that for each element that you're selecting a pair for, it will generate you 3 partners for each asset. And there will be a dedicated presentation for this tomorrow. Vilje will cover all the details, as well as show you some of the examples of how this is used and what the results are. Encourage you to join us tomorrow. And fine copula in general is a improvement over the standard copula strategy. And what authors claim in this paper is that over a rather long backtesting period, they were able to get really robust, good trading results from these strategies. There are also blog posts for this topic on our Hudson and Thames webpage in the research part of the webpage, if you would like to get more into detail. But I tell you beforehand that, hey, it's a rather complex topic to check out. But please check out the standard copula strategies, because they're a great tool to apply to your strategies and to your problems. Finally, the last element of our today's presentation will be the PCA and other approaches. It's rather short, because essentially here will only be the PCA approach, as we decided that maybe some of the other elements are not that worth being mentioned here. If you'd like to check out entire video dedicated to the PCA approach, there is a recording on YouTube that I think we made about a few months ago, and I there go in detail into how the PCA approach works, what are maybe the result that you should expect, and to which problems are you can you essentially apply the PCA approach. So yeah, the PCA strategy, it's written by Avellaneda and Lee, a rather great work, which in essence, so the main idea there is that you can take a set of assets and you can decompose their returns into a systematic and the idiosyncratic components. And the way you can achieve this split is to regress the returns of the elements to the returns of the some market sector representative thing. And this thing can be either a PCA eigen portfolio, where essentially we take eigen vector of a correlation matrix of your asset, and you would adjust it slightly to the variance, and you would get a set of weights to create a eigen portfolio, which is essentially a natural split, portfolio split of these assets. Or you can use just sector ETFs. So for example, if you are assuming US stocks, you may take sector ETFs for, I don't know, technology, industrial, etc., and then regress your stock returns on sector ETF returns, and you would essentially get the same idea of splitting returns into the systematic and idiosyncratic components. And then based on the performance of that idiosyncratic component that we're able to model, and we also apply the Ornstein-Uhlenbeck process there, we're able to generate trading signals. And this here essentially is a good example of a quasi-multivariate approach, because in the PCA setting, not the ETF setting, we would be trading one asset versus a whole portfolio of other assets from the same places here. There are also various model adjustments in this domain. For example, if we have the Ornstein-Uhlenbeck process, we may fix the drift, we may not fix the drift, we may adjust the returns that we have from the original assets by adjusting them by volatility, because then we would in some times filter out the kind of false positive activations of the strategy. It's a great paper for you to check out, or check some of our materials on the topic. And yep, unfortunately, that's it. Here will be a rather long set of references. As you can see, about 4 pages I have here, and some of them have links to original papers, as you can click and see them. Also, I just realized that I forgot to post the link to this presentation to the chat. So right after I'm done, and when I'll be seeing your questions and discussing them, you'll be able to see that link. If you'd like to save this presentation and go over it afterwards, you'll have the ability to do so. And I think that's it. Thank you so much for joining the first day of our pairs trading workshop. Please come tomorrow, as there's a lot to come. Follow me and follow Hudson and Thames if you would like to see more of this content. And now I would gladly answer any of your questions regarding the strategies, maybe regarding some of the products, or just discuss on various topics here and there. Thank you so much for attending, and I'm waiting for your questions.